Okay, so here in part two of residential electrical systems, we're going to jump into ground fault protection, R fault protection, wire sizes, wiring procedures, and fire alarm systems. So let's get to it. Okay, so ground fault and arc fault protection. Article 210.8. Now, I strongly recommend checking out your code book and going through Article 210.8 in the various areas. You have 210.8A, dwelling units, B, other than dwelling units, C, crawl space lighting outlets, and then D, which is a grocery list of 12 different locations in the 2023 that give you the areas that are requiring GFCI protection, which was a pretty good expansion between the 20 and 23 because of some additions of some 240 volt stuff. So 210.8, ground fault circuit interrupter protection for personnel shall be provided as required in 210.8 E and A. The ground fault circuit interrupter shall be installed in a readily accessible location. In other words, you can't put a GFI behind a refrigerator. 125 volt through 250 volts, single phase, 15 and 20 amp receptacles installed in the location specified in 210.8, A1 through 10 shall have ground fault circuit interrupter protection. And you see I'm adding some wording in here because I need to change my slides and update them to the 23. That 240 volt factor has been added in to where now we have requirements for ranges, cooking equipment, dryers, things like that. So you have in our listing of areas that are requiring the GFI protection for residential, you have bathrooms, garages, outdoors, crawl spaces, basements, kitchens, areas with sinks and permanent provisions for food prep, sinks, boathouses, bathtubs, laundry areas, and indoor damp and wet locations. And then, of course, it's under C now in the code, whereas crawl space lighting outlets, GFCI protection is required for those. And that is a result in the change in the code due to a fatality of someone getting in contact with a broken pull chain fixture in a crawl space and were electrocuted. So as I had said, pretty much this is the listing, all of these areas. Arc fault circuit interrupter protection. Now this is Article 210.12. And the definition for that is arc fault circuit interrupter is a device intended to provide protection from the effects of arc faults by recognizing characteristics unique to arcing and by functioning to de-energize the circuit when an arc fault is detected. So arc fault circuit interrupter protection shall be provided as required in 210.12 A, B, and C. The arc fault circuit interrupter shall be installed in a readily accessible location. And this goes through, and I'm not going to read all of these to you, but they go through the litany of different ways you can install arc fault protection, where you can provide it at a device at a certain point, but you got to run it in either MC cable or it's got to be an EMT. Up here, that's in front of you right now, a listed supplemental arc protection circuit breaker. They give all these different ways. Generally speaking, I would say that installers are going to be installing the protection at the panel using the overcurrent protection device. And in a lot of cases, we'll use dual function breakers that are GFCI and AFCI protection rather than dealing with all of this. There are some maximum length requirements depending on the length of the conductor, how long it can be and that sort of thing. A lot of different caveats to it. I think generally speaking, AFCI breaker at the panel. So AFCI versus GFCI. So you can use devices or you can use the breaker. And the devices, it's been a while since I priced one, but I thought they were in the 30 plus range. Breakers can be 40, 50 and up. If you got to buy both, well, then you've got the cost of both. So what's the point? And there's a 2-pole arc fault breaker. No, those are pretty pricey. GFCI and AFCI protection requirements have continued to increase in the last few code cycles, and GFCI protection reaches an all-time high in the 2020, and in the 2023, we've really seen some expansions. Wiring methods are affected in circuits that are under this type of protection, and some older appliances and some new, and old lamps and other household items do not function well on AFCI protection, motors in particularly. C states GFCI protection is not required on HVAC equipment until September 1st of 2026. The 2026 NEC states the same thing. I'm not sure exactly what's going to happen on September 1st, 2026. Evidently, it's going to be a big day. The 2026 NEC allows SP-GFCI protection, a new product now on the market, and this subject is discussed more in depth in some other presentations. If you look on our YouTube channel, we also have a short video explaining GFCI protection and SP-GFCI, and then I have a more long version that I think is around 20 or 30 minutes long that gives you a history of GFCI protection and really kind of spells out why SP-GFCI is out there and why it is a thing now. Residential electrical code, wire sizes, wiring procedures, and branch circuit breakdown. So here we got some wire sizes: 14 gauge, 12, 12.3, 10 gauge, 10.3, 14 gauge. And here's the standards. I remember when I first started in the trade, I had this written down on a little card and had it in my wallet until I memorized it. But this is what your typical ampacity capabilities are. Now, this is not, you go to 310.16 or table 310.16 in your code book, this is not going to go, it's not going to jive. So 14 gauge is 15 amps, 14.3 of course is 15, 12 gauge is 20 amps, 12.3 is 20 amps, 10 gauge is going to be 30 amps, and 10.3 is 30 amps. And if you're a studier of the code, this is just the foundation. There's some other variables to this: voltage drop, correction factors, all kinds of other pieces can come into play. This is just kind of foundation. So 8.2, 40 amps, 6.2, 6.3, and here we have those just so you can get a shot of that. 14 gauge is 15, 12 is 20, 10 is 30, 8 is 40, and 6 is 60. Those are the ampacity sizes as a residential worker that you need to know like the back of your hand. You need to have memorized those. I would be bold enough to say typically if you're installing the branch circuits, you're the apprentice, then you're probably not working outside of these ampacities much. And here's just another slide that kind of gives you a breakdown of that. Dropping down below the 14 gauge, 16 gauge at 10 amps and 7 amps at 18. Wiring procedures. Article 300.4, protection against physical damage. Cables installed through bored holes in joist, rafters, or wooden members. Holes shall be bored so that the edge of the hole is not less than 1.25 inches from the nearest edge of the wooden member. So I would hope we all know that a 2x4 is not 4 inches wide. So you got about a 3-inch 2x4. 1.25 inches means you're dead center of that 2x4. And the reason being you want to be there no matter what is because when the drywaller hangs his drywall and he puts that 1.25 inch drywall screw in there, if he misses the stud and your wire's right up next to the edge of it, he is going to get you. That's where the 1.25 inch comes from. And if you can't get that 1.25 inch, then you should be using nail guards or a protective method to avoid getting hit by the drywall guy. Romex cables must be secured within 12 inches of the enclosure or box, and the wires can be secured by staples, wire ties, or any approved means. If you go to the local supply house, you'll see in the picture there that red supporter up there in the top right or top left. There's all kinds of things like that you can use. I think there's another one there in the bottom. But they must be secured within 12 inches. That doesn't mean it has to be at 12 inches. I often recommend supporting at 6 inches because that's a little closer to the box, and oftentimes the knockouts on a plastic box are towards the back of the box, and stapling around 6 inches will pull those wires away from the back of the box as quickly as possible. But the code says within 12 inches of the box. So 12 inches or less, anywhere in that zone, you're good. NM cables shall be supported as to not damage the cable at intervals not exceeding 4.5 feet. And I like this picture of that bracket with the holes in it. That is a great way to support conductors. I like that. Wiring can also be run through wall studs, but must be directly center of the stud to maintain the code required distance of 1.25 inches from the edge of the stud. and this distance helps avoid being hit by the drywall guy. When cutting in switch boxes, the conductor that is the switch loop must be marked. The common conductor in a three-way switching set must be marked. And as far as markings, there's a variety of different ways. Everybody's got their own little thing. If I'm marking a switch loop, I will strip out the end of the switch loop. If it's a three-way and I've got two travelers and then I have a common, I will strip out the end of the common. So when I come back on the finish, I don't have to go in there and pull on wires or figure out whatever. I can tell what is what. Also, you'll notice the four gang box there in the picture. Everything's grouped together to where this is a switch, this is a switch, and this is a switch. You don't have to get in there and figure out what's what. The line side conductors for neutral and hots of a GFCI or AFCI device outlet must be marked. As I'd said, most commonly today, I think folks are probably using breakers rather than the devices, so that's really not an issue anymore. No more than 2 Romex sheaths under 1 staple. Branch circuit breakdown. General lighting circuits. Lighting circuits can be 15 amp or 20 amp, 14 gauge or 12 gauge wire. Notice I didn't mention it, but we're all talking copper. You could be using copper clad. I'm not really going to get into that in this video, but 14 gauge minimum on your lighting circuits. General purpose receptacles, they can be 15 amp or 20 amp. So 14 gauge or 12 gauge. I will commonly run them in 12. I think that's just a good practice, but it's not a code requirement. Unless it's an appliance circuit or something like that. There are requirements, obviously, that state specific sizing for appliances and equipment. Bathroom receptacle circuit, at least 120 amp, 120 volt branch circuit shall be provided to supply the bathroom outlets, and such circuits shall have no other outlets. One circuit going through the entire house, catching all of the receptacles at the bath vanities. Kitchen receptacles, as we saw earlier, 2 or more 20 amp, 120 volt small appliance branch circuits shall be installed to serve all wall, floor, and countertop outlets. Dishwashers, disposals, and microwaves and other appliances, in addition to the required receptacles specified by 210.52, a receptacle outlet to serve a specific appliance shall be permitted to be supplied from an individual branch circuit rated 15 amps or greater. Better make sure your load can handle that. I'd say typically as a rule, not a code requirement according to this statement, but as a rule, I would make everything a 20 amp minimum. Laundry branch circuit. 120 amp, 120 volt branch circuit shall be provided to supply the laundry clothes washer outlet. And the garage. At least 120 amp, 120 volt branch circuit shall be installed to supply the receptacle outlets in the garage, and this circuit shall have no other outlets. And I believe actually there's an exception that says you can serve outdoor outlets from this circuit. The clothes dryer. The electric clothes dryer requires a 30 amp, 240 volt 4-wire circuit. If it's a gas clothes dryer, it only requires a 120 volt circuit to power electronics and control systems in the appliance itself. It doesn't require a 240 volt plug. Electric range. Full standing electric ranges are typically 50 amp, 240 volt 4-wire. Gas ranges, same scenario as the dryer. HVAC. The heating and air conditioning system requires branch circuits specific to the type of equipment. So typically, gas furnace, or what's called a dual fuel furnace, will require a 20 amp, 120 volt branch circuit. Air conditioning unit on a 2,000 square foot home, average size condensing unit on that's going to be a 30 amp, 240 volt. As far as the size circuit, that really you have to get with your HVAC installer, and they can give you the nameplate ratings or the information on that unit. And the water heater typically is a 30 amp 240 volt for a 120 gallon or less water heater. More commonly we're seeing today are these instant water heaters. Some of those are gas, some of those are electric. Just depends on what size you're using. The branch circuits mentioned here are just the basic circuits typically installed. There are many other types of appliances, equipment, and power needs in a residential structure, depending on the design. And fire protection and alarm systems. Smoke, heat, and carbon monoxide protection. So smoke alarms are not a requirement mentioned in the National Electrical Code. They are actually a part of the building code. The building code states specific areas for these devices to be located. Bedroom or sleeping areas before the first bedroom, the common area, living room, top of the stairwell at the second floor, and basement adjacent to the stairwell. Now, and let me say this. This is, I'm in the southern Indiana and Kentucky area. What is required in your area? Because, I mean, people watch these videos from my channel all over the country. It could be different. Building code can be different in your area, so certainly refer to them. But I think this is pretty well the standard. You got to have one in each bedroom, all of the sleeping areas, one outside of those bedrooms, and a common area, second floor. You certainly don't put them in the kitchen. You can see why. And in the basement adjacent to the stairwell. While heat detectors are not required, they are often installed in the garage area, as a regular smoke detector would not work in that area, obviously. Although not required, carbon monoxide detectors are often installed in an area adjacent to the gas furnaces. Good idea there. And all of these devices are connected together. So you look at this graphic, you got a 120 volt circuit feeding it. So you got a black and a white wire coming into it. And then going in between each one of those units, you have a black, a red, and a white wire. They're not showing the equipment grounding conductor here, but nevertheless, all of those are connected together. Well, the red wire in this depiction is what is called the signal wire or interconnect. This is what sounds all the alarms in this system in the event of a fire. So let's say you got a house that has a 2-story, and up on the second floor, you're in the bedroom up there, but you got a smoke detector down in the basement and there's a fire down there. It's going to set up all those smoke alarms to let everybody know to get out. Power supply to a typical residential smoke alarm system is 120 volts, but all detectors are required to have a battery backup. And as a side note, there's no code that I'm aware of that says that you have to run a separate circuit to these. I always do just as a practice, but I don't believe it's required. Alarm systems that are monitored are different sector of the trade and have code and installation variances other than what has been discussed here. You got a ADT or whoever your alarm system is or alarm company, provide monitoring that, the system goes off, it calls the police for you or a fire department and what have you. So, in summary, residential electrical systems have advanced greatly in recent years. It is the #1 electrical system used by the world. The need for skilled, knowledgeable tradesmen to install these systems is always on the rise. These systems provide power to our lives. Quite frankly, it is something I've thought for a long time that the electrical systems that are in residential structures is becoming more and more complex, and you're not going to be able to just be a wire puller and install these type systems. You're going to have to be more tech savvy here now and in the future, even more so, in order to be able to install these systems. Okay, well, that's our presentation on residential electrical systems. Hopefully this has been very helpful to you. As you can see, there's a lot of moving parts to it. I had several code references in there from maybe the 17, the 20, and of course 23, and even I believe at one point I was referencing the 26. And one of the areas of the code that changes every code cycle typically is the residential. It seems like over the last 10, 15 years, if there's going to be changes, it starts in the residential. Matter of fact, I believe they started GFCI protection originally back in the 1960s in the residential sector, and then it would continually move up and up and up into the commercial sector. Same thing with AFCI protection as an example. So, hope this video has helped you, and be sure and check out our website at electriclab.org and our YouTube channel. Be sure and like and subscribe. And my name's Mike Barley, and I'm with Electric Lab. Thanks for watching.